Hey everyone, welcome back to another LeetCode problem solving video. Today we are tackling a fundamental string interview question. LeetCode 14, longest common prefix. The problem asks us to find the longest shared starting substring amongst an array of strings. For example, if our input is flower, flow, flight, all three words starts with the first letter F and L. The moment the letters don't match up across all words, our prefix stops. So for this example, the answer is FL. There are multiple ways to solve this, but today we are going to look at an incredibly clever, aggressive trick where we start by assuming the entire first word is the answer and then chop letters off the end until it fits. Let's look at strategy first and then we will jump into the code. Instead of checking the strings character by character across every single word at the same time, this solution uses a greedy horizontal reduction strategy. We start out by making a bold assumption. We assume the entire first word is longest common prefix and we store it in variable called substring. Then we look at the second word in the array. We ask, does this second word starts with our substring? If it doesn't, we trim the very last character of the back of our substring using popback and check again. We keep chopping off the end until the second word successfully matches our prefix. Once it matches, we take our newly shortened substring and compare it against the third word, shrinking it further if necessary. By the time we look through every single word in the array, whatever remains of our substring is guaranteed to be the longest common prefix for all of them. Let's see how this looks in C++ block by block. To begin, we capture the absolute first word of our string vectors strs of 0 and initialize it as our baseline prefix string called substring. Right after that, we kick off a standard for loop using index I starting at 1 to iterate through the rest of the words in our vector. So let's do that. So we will use substring for inside our loop. We need a way to check if the current word strs of I starts with our prefix. We use a nested while loop along with the built-in C++ .find method. .find substring searches for our prefix inside the current word and returns the starting index where it is found. If it returns 0, it means our prefix is sitting perfectly at very front of the word. So as long as .find does not equals 0, our prefix doesn't match the start and we immediately trim the last letter off using substring.popback. So while strs of I dot find substring not equals to 0, then substring dot pop underscore back. So we will trim the word. Once the inner while loop finds a match, the outer for loop moves to the next word and repeats the trimming process. After we have successfully verified our prefix against every single word in the vector, the loop terminates and we simply return our final proved substring. So after this, we will return substring. So first of all, let's run and check whether our code is working properly or not. Okay, so it is working properly. Now let's try run it. So let's run through a clean dry run to see this pursuing mechanic in action with our examples. Strs equals to flower, flow and flight. Initialization. We set str substring, a string substring equals to str of 0, which is flower. Now iteration 1 I equals to 1, strs of 1 equals to flow. We enter the for loop. We check, does flow start with flower? No. Dot find flower will not equal 0. The while loop activates. We call substring dot popback. Substring shrinks to flow. We check again, does flow starts with flow? No. We pop back again, substring shrinks to flow. We check again, does flow starts with flow? Yes. Dot find flow returns 0. The while loop exists. Now iteration 2. STRS of 2 equals to what? Flight. The outer loop moves to I equals to 2. We check, does a flight start with our current substring flow? No. The while loop activates. We pop back the O. Substring becomes FL. We check again, does flight start with FL? Yes. F flight starts with FL. So dot find returns 0 and the while loop exists. The outer loop runs out of words. Our function returns substrings, which is FL. This is absolutely perfect. Let us also submit the code to check it is passing all test cases or not. Okay, so it is passing all test cases. Now let's move towards the complexities. So time complexity, let S be the sum of all characters in string. In the absolute worst scenario, our while loop will repeatedly pop characters. The dot find function takes time proportional to the length of the string. Thus, the total time complexity is bounded by order of S, making it highly efficient because we only look at the characters necessary to trim our prefix. Space complexity, take a look at our variables. We aren't creating any extra vectors, hash maps or arrays. We are modifying our substrings variable completely in place. Therefore, our auxiliary space complexity is flawless, constant order of one space. And that is how you solve the longest common prefix by shrinking your way to the answer. It is an incredibly clean strategy that clean coded string operations make it look simple. If this block by block breakdown and visual try run helped you understand the problem better, remember to smash that like button, subscribe to the channel for more clean LeetCode walkthroughs, and leave a comment below if you have any questions. Thank you.